Hello everyone. In this video, we will find the moment of inertia and the radius of gyration of an area with the constant density covering the area bounded by y squared equal to x cubed, y equal to 8, x equal to 0, and with respect to the y-axis. So this is very important right here. Respect to the y-axis. It means that you are going to find IY. Okay, from IY you are going to find RY. And what is the formulas for RY? So RY is equal to the square root of IY divided by mass. And we need to find the mass before we can find the RY. Alright, so the first thing we are going to do is I am going to shade in the area that I need to work with. So first of all, the area covered by y squared equal to x to the exponent 3. So this is the function. And then x equal to 0, which is the y-axis, and y equal to 8, which is this line right here. So this is y equal to 8. So I'm going to shade in the area that I work with. Okay, so the next step, I'm working with the y-axis, and the elements that I'm going to choose has to be parallel to the axis of rotation. So in this case, it will be dx. Okay, so this one will be dx. And for dx, I know that I have to take the upper function minus the lower function. But to identify upper function and lower function, you need to look within the area that you have to highlight. Alright, so that label our axis of rotation is the y-axis and dx. And for dx, then I need to find the value of the x-axis, the upper and the lower limit. So right here should be 0, but this is the point that I have to look for. Okay, so this is the point that we need to look for later. So now I would like everyone to take a look at the area that we are working with. Okay, so right here you see your upper function should be your y equal to 8. So I'm going to label this as y2. My lower function is this function right here. Okay, y squared equal to x to the exponent 3. For me to solve for y, I need to take the square root of both sides. So in this case, I'm going to have y squared equal to x to the exponent 3. So I take square root of y squared. Give me square root of x to the exponent 3. So y will be equal to the square root of x to the exponent 3. So this is my y1. Okay, so this will be my y1. Okay, and it's equal to x raised to the exponent 2 over 3. I mean 3 over 2. Okay, so we'll raise to the exponent of 3 over 2 because your index will be your denominator, your exponent will be your numerator. So don't forget the formulas that you would like to remind everyone. A raised to exponent m over n will be equal to a to the exponent m, and the index is the denominator. Alright, okay. So the reason we convert this to this exponent is because we need to integrate later on. So therefore we need to convert that to exponent. But we are going to leave it like this, y1 equal to the square root of x to the exponent 3, so that we can solve for the upper limit, this point right here. So before we do that, I would like to review the formulas to find the IY. To find IY, the moment of inertia with respect to the y-axis will be equal to rho, the integral from a to b, because we are working with the vertical element, x squared y2 minus y1 dx. So you see that we are preparing all the steps before we can integrate. You see we're preparing that here's a to b. We need to solve for this point. We have x squared, y2, we found that, y1, we found that, but they are in terms of x. Alright, okay. So now let's find this point right here. To find this point, I'm going to let y1 equal to y2. So this a is equal to 0 for sure. It's very obvious that we know right here. This point is equal to 0. I'm going to let y1 equal to y2. Okay, so letting these two equal to each other, right? So y1 equal to y2. I am going to have square root of x to the exponent 3 equal to 8. Alright. In order for us to solve for x, you need to get rid of the square root first. Okay, so what you do is you will square this function. So I will have this. So I'm going to square both sides. Okay, so the square will get rid of the square root. So on the other side, I will have x to the exponent 3, and square the 8, you should have 64. Now solving for x, you are going to take cube root of x to the exponent 3 and cube root of 64. Therefore, you will have x equal to 4. Okay, so this is equal to 4. Alright, so it's a little bit of algebra that everyone will have to review in this case to find the upper limit. We will have to go through all of this stuff. Solving for x as a radical. Alright, okay, so now let's substitute everything into the integral, and then we can integrate. Okay, so my iy equal to rho. So in this case, I should have from 0 to 4. Okay, and I will have x squared multiplied by y2. y2 is equal to 8. And y1, okay, so equal to x raised to the exponent 3 over 2. Everything integrate in terms of x. So now you see that you have a differential factor of dx, and all your term is actually in terms of x. So before we can integrate, we need to multiply this inside the bracket. So now my will be equal to 8 times x squared is 8x squared. Okay, now I'm going to multiply x squared with x raised to the exponent 3 over 2. So if you multiply 2 powers with the same base, okay, so let's review that. That means you need to add the 2 exponents. Okay, another formula for everyone. So I am going to add 2 with 3 over 2. Okay, so this one I should have 4 over 2 plus 3 over 2, so I should have 7 over 2. So then my next term will be subtract x raised to the exponent 7 over 2 dx. Okay, so don't forget, we will just simplify our integrand in this case. To simplify integrand to integrate, because this 8 minus x raised to exponent 3 over 2 is, all of this is to the exponent 1. So you can go ahead and expand or distribute the term, and you can integrate each one individually. Okay, so I should write in here from 0 to 4. Okay, so what I'm going to do is I'm going to integrate on the next page. So don't forget that this step is only to simplify your integrand before you integrate. So now the next step is we are going to integrate. It means that I will take the integral sign off and I apply the fundamental theorem. Alright, okay. So now my I y is equal to rho. Okay, so let's see. The integral of 8x squared will be a times 1/3, so I will write it as 8/3 of x raised to the exponent 3. Okay, add 1 to the exponent divided by the result. So a divided by 3 times x to the exponent 3. So now my next step is you are having 7/2, right? You need to add 1 to the exponent. Okay, so integrate. Here you are going to add 1 to the exponent. 7/2 add 1 will be 9/2, right? So when you add 1 to the exponent is 9/2, you divide it by this result. That means you are going to multiply by the inverse of this fraction. So I'm going to subtract 2/9 multiplied by x to the exponent 9/2, and I evaluate this from 0 to 4. Okay, so don't forget that there's a few steps with the fraction here, and I don't want everyone to get confused. So this step that I highlight over here is only to distribute the term, right? Okay, you distribute the term so that you can simplify your integrand before you integrate. Now, with the 7/2 add 1, which is 9/2, this one is you to integrate. Okay, sometimes we add or work with fraction, we tend to get confused, so I just want to make sure that everyone understand that. Alright? Okay, so with 9/2, what I'm going to have is x raised to exponent 9/2. I will have to multiply by the reciprocal of this exponent. So the reciprocal of 9/2 is 2/9. Okay, so let's see what we have to do in this case. That means I will have to have rho multiplied by f of 4, right? Subtract f of 0. And now you see x is present in each of this term. Therefore, this one should be equal to 0. So you can ignore that term when you're knowing that it's equal to 0. Okay, so now Iy will be equal to a rho times 8/4, okay, and now x is 4 raised to the exponent 3, subtract 2/9, multiply by 4 raised to the exponent 9/2, okay. So I would like everyone to, what you want to do, you want to use the calculator, okay. Take 4 raised to the exponent 9/2. It should equal to 512. So this one should be 512. And now my next step is multiply this 512 by 2. Okay, so don't forget that. Now 8 times 4 to the exponent 3 divided by this should be 3. I'm sorry, I probably thinking before I'm writing. So this one should be a/3. So I should have 4 to the exponent 3. Okay, multiplied by a. It should give me 512/3. And I subtract this with 512 times 2 should give me 1024/9. Alright, okay. So perform this step. I should have Iy equal to 512 col over 9 times rho. Okay, so we will circle this. We put it in the cloud for now. So this is done. Okay, so we are finding IY. So our next step is to find the mass. So mass equal to what? So mass will be equal to rho multiplied by the area. Okay, so what is the area in this case? The area will be equal to the integral of a to b and y2 minus y1 dx in this case, because we are working with the vertical element. Alright, okay. So yes, I do give myself a lot of space. So now I'm going to write mass equal to rho times area. So that means rho times the integral from 0 to 4 of y2, which is a, minus y1, which is x raised to exponent 3 over 2, and everything in terms of dx. Okay, so we can go ahead and integrate here. Integrate this, I should have 8x. Okay, so integral of 8 is 8 times x, and then what I have is x raised to exponent 3 over 2. So what you do is you have 3 over 2 plus 1, right? 3 over 2 plus 1 is 5 over 2. Now, I am going to multiply this with 2 over 5. So x raised to exponent 5 over 2 multiplied by 2 over 5. And I'm going to evaluate this from 0 to 4. Close this. Then I should have rho multiplied by f of 4 subtract f of 0. But this should be 0 already, right? Because you have x in both terms, so you can ignore the f of 0. So let's continue on the next page. What I have here is I should have m equal to rho multiplied by 8 times 4 subtract 2 over 5 times 4 to the exponent 5 over 2. Alright, okay. So I would like everyone to use your calculator, and you can figure this out as 32. Okay, but let me review some fractions, some power exponent for you here. So we can easily find this not using the calculator. Okay, so I have 4 raised to the exponent of 5 over 2. Now 4 can be written as 2 square. Okay, so in this case you see that you take 2 multiply by 5 over 2, so you have 2 to the exponent 5, which is equal to 32. Okay, so you don't even need the calculator in this case. So m, so what you do is you multiply the 2 exponent. Okay, so what I do is I know 4 is 2 square, because with the square multiplied by 5 over 2, I can get rid of the denominator here. So in that case, I just have 2 to the exponent 5, in that case is equal to 32. But I think it's just more simpler if you just use a calculator. Alright, okay. So in this case, mass will be equal to, so I will have 32, right? Subtract 32 over 5. And I have to multiply that by 2. So it will be 64, 32 times 2 over 5. So 64 over 5. Okay, using your calculator, you should have this equal to 96 over 5 rho. Alright, okay. So here's what we have for the other answer. But we need to use this to find our y, right? So this will be IY divided by the mass, which is the square root of, so IY is figured out as 512 rho divided by 9. So I'm going to divide it by the mass, which is 96 rho over 5. So that means I am going to invert and multiply. Okay, so let's simplify this. Okay, so you see the row cancel out. 512 and then 96. I know that I can divide them both by 32. So I will divide this by 32. So I also divide this by 32. So this will give me in the so 512 divided by 32. So this will give me 80. And this should give me 27. Alright, so that should be 3 times 9. So I will have root 80 over root 27. Okay, so the next step I would like to show everyone is you need to simplify your answer. Okay, simplify your answer. We are going to review some radical in this case. So I will have root 80 divided by root of 27. So what you are going to do next is you are going to find a perfect square, multiply with a number will give you 80. A perfect square multiply by a number to give you 27. Okay, so a perfect square multiply by a number to give you 80. That should be 16 times 5. Okay, so 16 times 5. That will give you 80. And 27 is 9 times 3. Okay, 9 is a perfect square. Then 16 is also a perfect square. Perfect square means I can raise this 4 square is equal to 16. And here I should have 3 square equal to 9. So that means you can bring this across the radicand. So that means you will have 4 root 5. You will have 3 root 3. Okay, and to give the correct answer, you need to rationalize the denominator. Okay, to simplify your answer in simplest form, it needs to be rationalized because you cannot have the radical as the denominator right here. Alright, so now the next step is I have to multiply by root 3. Okay, so this step is to rationalize the denominator. Okay, so first step is to simplify your radical. Okay, 80 over 27. Then you break it into a square root of 80 divided by square root of 27. And then you have to find the perfect square, bring it outside to simplify your radical like this. So 4 root 5 is a simplified radical. 3 root 3 is a simplified radical. But this answer is a form of fraction. And for a simplified answer as a fraction, you cannot have the radical as the denominator. Therefore, you have to apply the concept called rationalizing denominators. So I multiply by root 3 to get rid of the root here. So, but if I multiply the denominator by root 3, I have to multiply by the same thing on the denominator for the numerator as well. So in this case, I should have 4 times square root of 15 divided by 3 times 3, which is equal to 9. Okay, so the answer will be 4 root 15 divided by 9. So Therefore, Ry is equal to 4 root of 15 divided by 9. And then you cannot simplify this any further. Alright, so the answer in radical require you to put it in the simplest form. So in simplest form mean that your radical has to be in simplified form. So 80 over 27, I know that I need to simplify this by breaking this into two radicals. Okay, find the perfect square for root 5 is the simplified radical of root 80. Root 3 is the simplified radical of root 27. After you get this answer, for you to have a simplified exact answer, you cannot have is as the decimal to be exact, and you to be simplified, you need to get rid of your square root of 3. Square root of 3, I multiply the top and the bottom by square root of 3. Root 3 times root 3 will give me 3. Root 5 times root 3 will give me root 15. And then now simplify, I have 9 as a denominator, and that is my final answer. So we answer all the questions that they asked us to find. We are finding the Ry. We also finding mass so that we can use it to find Ry. We can find the Iy as well, as they have asked us to find in this question. So for this particular area, what you have is the moment of inertia will be equal to root of will be equal to 512 times the density divided by 9, and then Ry will be found as 4 times root 15 over 9. Okay, so in this case you don't have any more row because the row cancel out. Alright, so for this one question, it takes a while to work with. Okay, so few formulas to work with, a lot of algebra involved as well in terms of the radical and the exponent. So I would like everyone to make sure that you go over this example once again, and then also review your concept of exponent, and then rationalize the denominator. So I have a few minutes here, so I just want to give everyone a few formulas. Okay, so root a over b. Let's say you have root n of that, you can make the n root of a divided by the n root of b. Okay, so this one formulas for simplifying your radical. Alright, thank you everyone.